Mixing 120 volts and 277 volts circuits in a single electrical box requires careful consideration and adherence to safety protocols. Here are several approaches to consider, along with crucial safety guidelines. Firstly, insulated voltage transformers, often abbreviated IVT, can be used. The purpose of an IVT is to provide isolation between the higher voltage, the 277 volt circuit, and the lower voltage, the 120 volt circuit. In this configuration, you would connect the 277 volt switches to the secondary side of the IVT. The primary side of the IVT would connect to the 277 volt circuit. The 120 volt switch is then connected to the 120 volt circuit as you normally would. This approach ensures that the two voltage levels are electrically isolated from each other, enhancing safety. Secondly, another option involves utilizing a two-circuit junction box. These junction boxes are specifically designed for dual-circuit applications where different voltage levels are present. Inside the junction box, you would physically separate the 277 volts and 120 volt circuits using a barrier. This barrier prevents accidental contact between the circuits. Connect the 277 volt switches to the 277 volt circuit and the 120 volt switch to the 120 volt circuit, maintaining the separation within the box. Thirdly, if space and practicality allow, consider installing separate boxes. This entails removing the existing full gang box and installing two distinct boxes. One box would house the 277 volt circuit and its associated switches, while the other box would house the 120 volt circuit and its switch. When implementing this approach, ensure that the boxes are properly spaced and aligned to meet code requirements and to facilitate safe wiring practices. Regardless of the chosen approach, several safety considerations are paramount. Always wear appropriate personal protective equipment, commonly referred to as PPE, when working with electricity. This includes safety glasses, insulated gloves, and appropriate clothing. Before commencing any electrical work, ensure that the circuit breakers for both the 277 volts and 120 volt circuits are turned off. This step is crucial to prevent electrical shock. Utilize a reliable voltage tester to verify that the circuits are indeed de-energized before touching any wires or components. Clearly label all wiring and switches to avoid confusion during installation and future maintenance. Proper labeling helps prevent accidental misconnections and ensures that anyone working on the system in the future can easily identify the different circuits. Before energizing the circuits after completing the work, it is strongly recommended to have a qualified electrician inspect the installation. A professional electrician can verify that the wiring is correct, the connections are secure, and that all safety standards have been met. The National Electrical Code, or NEC, provides guidelines and regulations for safe electrical installations. Consult the NEC for specific requirements related to mixing voltage levels and for proper wiring methods. When selecting components such as switches, junction boxes, and transformers, ensure that they are rated for the appropriate voltage and current levels. Using components that are not properly rated can lead to overheating, equipment failure, and potentially hazardous situations. Grounding is a critical aspect of electrical safety. Ensure that all circuits and equipment are properly grounded according to the NEC requirements. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. When working with electrical boxes, use appropriate wiring methods and connectors. Ensure that all connections are secure and that wires are properly protected from damage. Use cable clamps or connectors to secure wires entering and exiting the box. Pay close attention to wire fill requirements for electrical boxes. Overfilling a box can lead to overheating and potential fire hazards. Consult the NEC for wire fill calculations and use appropriately sized boxes for the number of wires and devices. When routing wires, avoid sharp bends and protect wires from abrasion. Use conduit or other protective measures when wires are exposed to physical damage. Keep wiring neat and organized within the electrical box. This makes it easier to troubleshoot and maintain the system in the future. Use wire ties or other methods to bundle and secure wires. Consider the ambient temperature when selecting wiring and components. High ambient temperatures can affect the performance and lifespan of electrical equipment. Use components that are rated for the expected temperature range. Regularly inspect electrical installations for signs of damage or wear. Look for loose connections, cracked insulation, and other potential problems. Address any issues promptly to prevent further damage and ensure safety. If you are not comfortable working with electricity or if you are unsure about any aspect of the installation, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely. When working with 277-volt circuits, be aware of the potential for arc flash. Arc flash is a dangerous electrical phenomenon that can occur when there is a short circuit or fault in the system. Wear appropriate arc flash PPE such as a face shield, gloves, and protective clothing when working on or near energized 277 volts equipment. Follow lockout/tagout procedures to ensure that circuits are de-energized and cannot be accidentally re-energized while you are working on them. This involves placing a lock and tag on the circuit breaker to prevent it from being turned on. Use a calibrated multimeter to measure voltage and current levels. This ensures that you are working with the correct voltage and that the circuit is not overloaded. When splicing wires, use appropriate connectors and tools. Ensure that the connections are secure and that the wires are properly insulated. Avoid using tape as the sole means of insulation, as it can dry out and become ineffective over time. Consider using surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protection devices can help prevent damage to equipment caused by lightning strikes or other electrical disturbances. When working in damp or wet locations, use ground fault circuit interrupters, often referred to as GFCIs, to protect against electrical shock. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing serious injury. Be aware of the potential for electromagnetic interference, often called EMI, when mixing different voltage levels. EMI can disrupt the operation of sensitive electronic equipment. Use shielded cables and filters to minimize EMI. Follow all applicable electrical codes and regulations. These codes are designed to ensure the safety of electrical installations and to prevent fires and other hazards. Keep electrical boxes and equipment clean and free from dust and debris. Dust and debris can accumulate and cause overheating or other problems. When replacing switches or other devices, use components that are of the same type and rating as the original components. Using incompatible components can lead to malfunctions or safety hazards. If you are unsure about any aspect of electrical work, consult with a qualified electrical engineer or inspector. These professionals can provide expert advice and guidance to ensure that the work is done safely and correctly. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. By following these guidelines and consulting with qualified professionals, you can safely manage mixed voltage circuits in a single electrical box. Remember to always prioritize safety and consult with a qualified electrician when dealing with electrical installations, especially when mixing different voltage levels. Neglecting safety precautions can lead to serious injury or property damage. Electrical codes and regulations vary depending on location, so it's important to consult with local authorities and follow the specific requirements in your area. Ignoring electrical codes can result in fines, penalties, and potentially unsafe installations. Before starting any electrical work, take the time to thoroughly plan the project and gather all the necessary materials and tools. Having everything you need on hand will make the job easier and safer. Use a checklist to ensure that you don't forget any important steps. This can help prevent errors and ensure that the job is done correctly. Take breaks when needed to avoid fatigue and maintain focus. Electrical work requires concentration and attention to detail, and it's important to be well rested and alert. If you are working in a confined space, ensure that there is adequate ventilation. Electrical equipment can produce heat, and it's important to prevent overheating. If you are working near water, take extra precautions to prevent electrical shock. Use GFCIs and avoid touching electrical equipment with wet hands. When working with ladders or scaffolding, follow all safety guidelines to prevent falls. Falls can result in serious injuries, and it's important to take precautions to protect yourself. If you are working on a live circuit, use insulated tools to prevent electrical shock. Insulated tools are designed to protect you from electrical current. Be aware of the potential for static electricity when working with sensitive electronic components. Static electricity can damage components, and it's important to take precautions to prevent static discharge. When disposing of electrical waste, follow all environmental regulations. Electrical waste can contain hazardous materials, and it's important to dispose of it properly. Keep children and pets away from electrical work areas. Electrical work can be dangerous, and it's important to prevent accidents. Consider installing arc fault circuit interrupters, often referred to as SIs, to protect against electrical fires. SIs are designed to detect arc faults and quickly interrupt the circuit, preventing fires. When working with aluminum wiring, use special connectors and techniques to prevent corrosion. Aluminum wiring can corrode over time, leading to loose connections and potential fire hazards. Regularly inspect electrical cords and replace any that are damaged or frayed. Damaged cords can be a fire hazard. Avoid overloading electrical outlets and circuits. Overloading can cause overheating and potential fire hazards. Use power strips with surge protection to protect electronic equipment from voltage spikes. Power strips can also help to organize cords and prevent clutter. Keep flammable materials away from electrical equipment. Flammable materials can ignite if they come into contact with hot electrical component. When using extension cords, use cords that are of the appropriate gauge and length for the application. Using undersized or excessively long extension cords can lead to voltage drop and overheating. Consider using energy-efficient lighting and appliances to reduce energy consumption and save money. Energy-efficient products can also help to reduce the strain on electrical circuits. If you are selling or renting a property, ensure that the electrical system is up to code and in good working order. This can help to prevent problems and ensure the safety of occupants. Keep records of all electrical work that is performed, including dates, descriptions of the work, and the names of the electricians who performed the work. This can be helpful for future maintenance and troubleshooting. Educate yourself and others about electrical safety. The more you know about electrical safety, the better equipped you will be to prevent accidents. Remember that electrical safety is an ongoing process. It's important to stay informed about the latest codes and regulations and to take precautions to protect yourself and others from electrical hazards. By following these guidelines and consulting with qualified professionals, you can safely manage electrical systems and prevent accidents. The complexity of safely integrating different voltage circuits such as 120 volts and 277 volts in a single electrical box necessitates a comprehensive understanding of electrical principles, safety standards, and local codes. The suggestions outlined, including the use of insulated voltage transformers, dual circuit junction boxes, and separate enclosures, are each viable depending on the specific circumstances and project requirements. However, none of these should be implemented without a thorough risk assessment and consultation with a licensed electrician. Insulated voltage transformers, IVTs, offer a robust solution for isolating circuits of differing voltages. These devices effectively create an electrical barrier, preventing the higher voltage 277 volt circuit from directly interacting with the lower voltage 120 volt circuit. The selection of an appropriate IVT requires careful consideration of its voltage ratings, power handling capabilities, and compliance with relevant safety standards. The installation process must adhere strictly to manufacturer specifications and applicable electrical codes to ensure proper operation and safety. Dual circuit junction boxes are specifically designed to accommodate multiple circuits within a single enclosure while maintaining physical separation between them. These boxes typically incorporate internal barriers or compartments that prevent accidental contact between circuits of different voltages. The selection of a dual-circuit junction box should take into account the number and size of conductors to be accommodated, as well as the environmental conditions in which the box will be installed. Proper wiring practices, including the use of appropriately sized conductors and secure connections, are essential for ensuring the safe and reliable operation of the circuits. Separating the 120 volts and 277 volt circuits into distinct enclosures offers the most straightforward approach to preventing inter-circuit interference and ensuring safety. This method eliminates the need for specialized components or complex wiring configurations. However, it may require additional space and labor to install separate boxes and route conductors accordingly. The selection of appropriate enclosures should take into account the environmental conditions, the size and number of conductors, and any applicable code requirements. Regardless of the chosen method, adherence to established safety protocols is paramount when working with the electrical systems. Prior to commencing any work, ensure that all circuits are de-energized by disconnecting the appropriate circuit breakers. Use a calibrated voltage tester to verify that the circuits are indeed energized before proceeding with any wiring or modifications. Wear appropriate personal protective equipment (PPE), including insulated gloves, safety glasses, and appropriate clothing to protect against electrical shock and other hazards. Clearly label all conductors and components to facilitate easy identification and prevent accidental misconnections. Use appropriately rated tools and equipment for the specific tasks being performed. Avoid working in damp or wet conditions, as this increases the risk of electrical shock. Follow all applicable electrical codes and regulations, including the National Electrical Code (NEC) and any local amendments. Consult with a licensed electrician or electrical engineer if you have any questions or concerns about the safety or proper installation of electrical systems. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. By following these guidelines and consulting with qualified professionals, you can safely integrate different voltage circuits in a single electrical box while maintaining compliance with all applicable codes and regulations. Additionally, consider the long-term implications of each approach. For example, using IVT may introduce additional energy losses and require periodic maintenance. Dual-circuit junction boxes may be more difficult to access and modify in the future. Separating the circuits into distinct enclosures may require more space and increase the overall cost of the installation. Therefore, it is important to carefully weigh the pros and cons of each approach before making a decision. Furthermore, it is essential to document all electrical work that is performed, including detailed wiring diagrams, component specifications, and test results. This documentation can be invaluable for future maintenance, troubleshooting, and modifications. Keep the documentation in a safe and accessible location. Regularly inspect electrical systems for signs of damage, wear, or malfunction. Address any issues promptly to prevent further damage and ensure safety. Consider implementing a preventive maintenance program to proactively identify and address potential problems before they escalate. By following these best practices, you can ensure the safe, reliable, and efficient operation of electrical systems for years to come. Remember that electrical safety is a shared responsibility. Everyone who interacts with electrical systems should be aware of the potential hazards and take appropriate precautions to protect themselves and others. Promote a culture of safety and encourage employees to report any safety concerns without fear of reprisal. Provide regular training on electrical safety topics to ensure that employees are knowledgeable and competent. By working together, we can create a safer environment for everyone.